Okay, my talk, as you know, is on adaptation to climate change, impacts on our transportation infrastructure. I want to state off at the top that one of the things I will not be talking about is the effects of transportation on climate change. That's a whole different topic and it can go on. But adapting to climate change is quite a timely discussion today because of the recent release of several reports. So these are my primary sources of information. I'll start out with potential impacts of climate change on U.S. transportation. This is the recently released report from the NRC Transportation Research Board. It was just released last month. And as they were working on this report, they realized they needed some additional information. And so they commissioned several articles. And one of the articles they commissioned me to write was Climate Variability and Change with Implications for Transportation. And this report, our paper features prominently in the NRC report, briefly on it, that this was well beyond what I could have done alone, but I was fortunate to line up a good team, both of Marjorie McGurk and Tammy Houston from my institution at NOAA's National Climatic Data Center, Andy Horvitz from the National Weather Service, and Michael Weiner from the Department of Energy's Lawrence Berkeley Labs. And this report as well was released at the same time as the NRC report was. The third report is Weather and Climate Extremes in a Changing Climate. This is a U.S. Climate Change Science Program Synthesis and Assessment Report. It's number 3.3. Its probable release date, the last I heard, is we're expecting late April to probably be able to formally release this. I'm one of the many authors on it, so I know what's in there before it's released. And the fourth one, again, was just released last month, The Impacts on Climate Variability and Change on Transportation Systems and Infrastructure, the Gulf Coast Study. So this is a climate change report that focuses just on transportation in the Gulf Coast, and that's CCSP 4.7. So to get us all in the same mindset, what do we mean by transportation? You know, it's planes, trains, automobiles, as well as trucks and buses, both commuter and long haul. And often these are related that, you know, if cars can't get to the airport because of snowstorm, the airport is just as effectively closed as if the planes couldn't get to the airport. Dealing with inland barge traffic, ferries, nearshore and ocean cargo and up the St. Lawrence Seaway, and then pipelines as well. When we started our analysis, we tried to figure out, in order to understand how it would be impacted by climate change, we'd see what weather and climate issues transportation was sensitive to. And for weather, it was primarily extremes. Temperature extremes, precipitation extremes, and storms. And this makes sense because the infrastructure was designed to handle most of the common weather that we have. You know, it may slow things down a little bit, but basically it can handle the common occurrences. It's the more extreme events that have problems. For climate, it's primarily that we're talking about is general warming, drought, sea level changes, and potentially Arctic sea ice. I will be going through to get a sense of what how these impact transportation, each of these topics later, both in weather and climate. Okay, so what is adaptation to climate change? Just Tuesday of last week, Virginia Burkett from the USGS made a comment. She said, adaptation is just better planning. I like that view of adaptation, you know. And planning, we look into the future quite a ways. Roadways typically about 25 years into the future. Railroads, 50 years. That bridges and underpasses are designed with 100 years of service in mind. And major hubs, we should look even farther out because, you know, if you build an airport, you're going to start stimulating growth and development around the airport. So let's deal with an example of climate change. Say you've been asked to design a new bridge. So the things you take into consideration, there's many different aspects, but a couple of them are current traffic and then potential future traffic. And similarly for adaptation, you look at current weather, but you also look at potential future weather and climate. And an example of that is this beautiful bridge here. This is the Confederation Bridge, which is about 8 miles long. It connects Prince Edward Island to Canada, the Canadian mainland. And the design for this took into account the possibility of a 1-meter sea level rise due to climate change when they built this. So that's an example of adaptation. In our report, there's three basic analyses that we used to see how the climate was changing in aspects that impacted transportation. I want to show these briefly to you. One is looking at extremes, changes in extremes. These were from daily data, and we used a formulation for a variety of different indices that was coordinated by a World Meteorological Organization expert team on climate change detection and indices. So these are robust measures of extremes, and this shows the number of days in January with temperature less than the 10th percentile. So these are the very cold days of the year, and the percentiles are determined from 61 to 90. But you can see that the 70s were quite cold a lot of days, and we've had a decrease since then. So there's been fewer cold days. We also use model projections. And these are all the models, the results from all the models that were run for the IPCC Fourth Assessment Report. There's about 20 models in here. And we looked at them in different regions of the country. We also looked at some indices that because of the coordination by this WMO expert team, some of the models saved off some of the indices derived from daily data. And I'll show you an example of that later. If you look at these trends up, there's various scenarios that were used of how much CO2 would be changing and other greenhouse gases. And they're based on kind of a storyline about technology and conservation and population changes. But should this scenario verify that what we're seeing here is the trend up, you can see the median line, and then of course sort of the gold color. This is what is very likely. It's likely that the climate change would be within that realm, and it's very likely it would be within the realm of the gray. And the scale here on the y-axis is equivalent of going from Minneapolis, Minnesota to the southern tip of Illinois, Cary, Illinois. So when you see a change of equivalent from here to here, and if we're dealing with Minneapolis, that'd be equivalent to moving down to about St. Louis in terms of temperature change. So the projections in this fairly CO2-insensitive future is considerable warming. And all the models tend to agree on this quite well. So I wanted to show precipitation as well, and partly because to show that the models do not agree, that there's a great deal of certain uncertainty, or rather different possibilities into the future. So you can see here that the median may be going up slightly, but there's a big spread here in between. Some of the models are showing increases and some decreases. So we're quite uncertain about how total precipitation will be changing in the future based on the model runs. But there are some aspects of precipitation that are quite well supported by all the model runs, and we have an index of that I'll show you later. We also looked at future local extremes. I mean, transportation impacts locally. And this is a threshold that impacts 110 degrees Fahrenheit. In Dallas, it impacts maintenance on transportation. It impacts potentially railroad track buckling and stuff. So this is taking the model projections into the future and analyzing the local possibilities for the number of days above 110 in Dallas. And currently is the blue. So we currently have about a 30% chance of one day above 110, and perhaps a 5% chance of 3 days above 110. If we look out 50 years into the future, which is the red curve, we're seeing that there's like a 75% chance of at least one day above, and perhaps a 20% chance of 5 days above that. So these are kind of relevant metrics to look at how transportation might be impacted.